Given the vectors A equal to I minus j plus 2k, B equal to 2I plus j plus k, and C equal to I plus 2j minus k. Find A cross B cross C. This is a triple cross product. So let us determine it. First of all, we are going to determine the cross product of A and B. All right. So the cross product of A and B, let's determine that. We have I, J, and K. The coefficient of I for A here, the coefficient is 1. For B, it is 2. So we have 1, 2. The coefficient of J for A is minus 1. For B, it is what? 1. Minus 1, 1. The coefficient of K for A is 2, and for B is 1. 2, 1. Alright, so what is this equal to? Evaluating the determinant of a 3 by 3 matrix that we have, I has a plus. So we have plus I, open a bracket. Eliminate this column of I, eliminate this row of I, we have minus 1, 2, 1, 1. So we evaluate the determinant of that 2 by 2 matrix. Minus 1 times 1 is minus 1. 1 times 2 is 2, minus 2. J has a sign of minus. Eliminate this column of J, eliminate this row of J. We have 1, 2, 2, 1. 1, 2, 2, 1. 1 times 1 is 1. 2 times 2 is 4. K has the sign of plus. Eliminate this column, eliminate this row. We have 1 minus 1, 2, 1. So 1 times 1 is 1 minus 1 times 2, that's minus 2. So what is this equal to? Minus 1 minus 2 is minus 3. So we have minus 3i. 1 minus 4 is minus 3. Minus 3 times minus j is plus 3j. Alright. This is 1 plus 2. Alright, so 1 plus 2 is 3. 3 times k is 3k. So this is the cross product of A and B. What now is the triple vector product or the triple cross product of A, B, and C? So this is it now. The triple cross product of A, B, and C is equal to this now, minus 3i plus 3j plus 3k cross, what is vector C? This, I plus 2j minus k. So we're going to evaluate that cross product now in the same way we did it for A cross B. Alright, so we have ijk, ijk. So the corresponding coefficients, we have I is minus 3 here and 1 here. So we have minus 3, 1. For J, 3, 2. 3, 2. For K, 3 minus 1. 3 minus 1. This is A cross B cross C. Alright. So this is equal to I is positive. Eliminate this column of I, eliminate this row of I. We have 3, 3, 2, minus 1. So 3 times minus 1 is minus 3. 2 times 3 is 6, minus 6. J is negative, minus J. Eliminate this column of J and this row of J. We have minus 3, 3, 1, minus 1. Minus 3 times minus 1 is 3. Minus 1 times 3 is 3. Okay. K is positive. Eliminate this column and this row. We have minus 3, 3, 1, 2. So minus 3 times 2 is minus 6. Minus 1 times 3 is 3. So what's this equal to? Minus 3 minus 6 is minus 9 times I is minus 9I. 3 minus 3 is 0 times j or minus j is still 0. So this one is out. Minus 6 minus 3 is minus 9. Minus 9 times k, that's minus 9k. So this is the product, the cross product of A, B, and C. Find a unit vector parallel to the sum of A equal to 2i plus 4j minus 5k, B equal to I plus 2j plus 2k, and C equal to 2i plus 4j plus 10k. Here we are to find a unit vector that is parallel to the sum of these three vectors. So first of all, let us determine the sum of the three vectors. A plus B plus C. What is it equal to? A is 2i plus 4j minus 5k, plus B is I plus 2j plus 2k, and C, that's plus vector C, 2i plus 4j plus 10k. Alright, so the sum is equal to 2i plus I, that's 3i. 3i plus 2i is 5i. 4j plus 2j, that's 6j. 6j plus 4j is 10j. Minus 5k plus 2k is minus 3k. Minus 3k plus 10k is 7k. So this is the sum or the resultant of the three vectors A, B, and C. Now, the unit vector parallel to the sum of A, B, and C is this. The sum of the vector A, B, and C, A plus B plus C, the sum of these vectors divided by the modulus of the sum of the vectors A plus B plus C. So we need the modulus of this resultant, 5i plus 10j plus 7k. Okay, so let us determine that. The absolute value of the sum of A and B and C is this. The square root, going by the formula for magnitude of a vector, the magnitude of a vector is given by the formula, right? The square root of A squared plus B squared plus C squared. So A here is 5, B here is 10, and C here is 7. So we have 5 squared plus 10 squared plus 7 squared. Okay, 5 squared is 25, 10 squared is 100, 7 squared is 49. That is equal to the square root of 174. Alright, so what is the unit vector now that is parallel to the sum of the three vectors? Okay, so A plus B plus C is this. That is 5i plus 10j plus 7k. And the resultant, the modulus of this resultant is the square root of 174. So divided by what? 174. This is the unit vector that is parallel to the sum of the three vectors A, B, and C. Find the value of x if the cross product of this vector I plus 2j plus s minus 2k and the vector minus 3i plus j plus sk is this 7i minus 14j plus 7k. Okay, the question is saying that the cross product of these two vectors is equal to this. Okay, let's determine the value of x. So from the question, we have that the cross product of this and this, which is I plus 2j plus s minus 2k, okay, s minus 2k cross, right, is a cross product, minus 3i plus j plus sk is equal to 7i minus 14j plus 7k. Okay, this is 14j. Now, what is the cross product of these two vectors? For cross product, this is it. We have the determinant, okay, I, j, and k, and their corresponding coefficient. The coefficient of I here is 1, of j here is 2, of k here is x minus 2, right? The coefficient of I here is minus 3, of j is 1, and of k is x. And this cross product is equal to 7i minus 14j plus 7k. Okay, let's see. Let's evaluate. This is the determinant of a 3 by 3 matrix. So let's evaluate it. So the principle goes, bring the first element out here, I. It has a plus. Okay. Eliminate this column of I. Eliminate this row of I. So close this up. Close this up. What's left? We have the entries 2x minus 2, 1x, right? So we evaluate the determinant of this matrix. 2 times x is 2x minus 1 times s minus 2 is still s minus 2. So we have x minus 2. Then we come here. J has a minus. Bring j out. This is plus minus plus, alright? So j has a minus. Then close this column of j and close this row of j. Close this row. We'll be having the entries 1x minus 2 minus 3x, right? 1x minus 2 minus 3x. So let's evaluate the determinant of that 2 by 2 matrix. 1 times x is x minus then minus 3 times this as minus 3 multiplying x minus 2. Okay, then the last entry here, which is k, it has a plus. Okay, so eliminate this column of k, eliminate this row. We have 1, 2, minus 3, 1. 1 times 1 is 1, minus 3 times 2 is minus 6. Everything is equal to this 7i minus 14j plus 7k. Okay, let's simplify. We have I into, this is minus x minus 2. So 2 minus x is x. Minus minus is a plus. Then minus j. We have x. Okay, minus minus is a plus. Okay, so we have plus 3 outside. Plus 3 times x is 3x. Plus 3 times minus 2 is minus 6. And here we have k. 1 minus minus 6 is 1 plus 6, and that's 7. So equal to 7i minus 14j plus 7k. Okay, so we have this I into x plus 2, right? I want to take this minus inside, right? S plus 3x is 4x. Okay, so we'll be having 4x minus 6. 4x minus 6. If I send this minus inside, it will now be 6 minus 4x. You get it? So we have it plus j into 6. The 6 becomes positive and the 4x becomes negative. Then plus 7k equal to 7i minus 14j plus 7k. So let's now compare coefficients. Comparing coefficients. The corresponding coefficient of I, of j, and of k will be set equal to each other. Alright, let's see. It is obvious that for k here it is 7. That is, the coefficient of k here is 7. The coefficient of k here at the left is also 7. Okay, so that one is settled. Then I has a coefficient of 7 here. I has a coefficient of s plus 2 here. So we can set s plus 2 equal to 7. So s plus 2 is equal to 7. S plus 2 equal to 7. And this means that s is equal to 7 minus 2, which is equal to what? 5. So the value of s is 5. Now let's check for this. 6 minus 4x equal to minus 14. The coefficient of j here is 6 minus 4x. And here it is minus 14. So let's set the two of them together equal to each other. 6 minus 4x equal to what? Minus 14. So minus 4x is equal to minus 14. If the 6 cross, it turns to a minus 6. Minus 14 minus 6 is minus 20. So minus 4x is equal to minus 20. Minus take away minus. 4 here is 1, 4 here is 5. So x is equal to what? To 5. So x is equal to 5. That is the value of x for this particular problem. If A, the vector A equal to 2i minus j plus 3k, B is 3i plus 2j plus k, and C is equal to I plus mj plus 4k, are coplanar. Find the value of m. The principle is that for three vectors that are coplanar, their triple scalar product is equal to 0. So for A, B, and C that are coplanar, A dot B cross C is equal to 0. This is the condition for coplanarity of three vectors. So let us determine the triple scalar product of A, B, and C. Right? In the determinant form of the matrix. So the coefficient of I for the three vectors are 2, 3, and 1. So we have 2, 3, 1. For J, they are minus 1, 2, m. Minus 1, 2, m. For K, they are 3, 1, 4. 3, 1, 4. So what the question is saying, that the triple scalar product is equal to 0. So let's evaluate this. Right? So we bring 2 out with a sign of plus. Eliminate this column of 2, eliminate this row of 2. We have the entries 2, 1, m, 4. Okay, so the determinant of this matrix now is 2 times 4, 8, minus 1 times m, n. Then the next entry here is minus 1. That entry has a minus sign. Alright, this is plus, minus, plus. So attach the minus 1 to it as well. And open a bracket. Eliminate this column of minus 1, eliminate this row of minus 1. We have the entries 3, 1, 1, 4. 3, 1, 1, 4. So the determinant of that matrix is 3 times 4, 12, minus 1 times 1, 1. Then 3 here has a sign plus. Eliminate this column, eliminate this row. We have the entries 3, 2, 1, m. 3, 2, 1, m. So the determinant is 3 times m, 3m, minus 1 times 2, 2, all equal to 0. So let's solve this equation and determine the value of m. Okay, so this is 2 times 8 is 16. 2 times minus m is minus 2m. This is plus 1, right? Minus minus is a plus. So we have plus 1 times 12, which is 12. Right. Okay, this is actually 12 minus 1, which is 11. Okay, let's go ahead. This is plus 1 times 12, 12. Plus 1 times minus 1 is minus 1. Okay. 3 times 3m is 9m. 3 times minus 2 is minus 6 equal to 0. 12 minus 1 is 11. 16 minus 6 is 10. 10 plus 11 is 21. Minus 2m plus 9m, which is 9m minus 2m, is plus 7m equal to what? 0. So 21 is equal to minus 7m. Divide both sides by minus 7. M is equal to minus 3, right? So m is equal to minus 3. So the value of m, for which the three vectors a, b, and c are coplanar, is minus 3. And this is option E. Find the value of lambda if 2i minus 3j plus 5k is orthogonal to 3i plus lambda j minus 2k. For two vectors that are orthogonal, their dot product is equal to 0. Okay, so the dot product of the two vectors 2i minus 3j plus 5k dot 3i plus lambda j minus 2k equals 0. So this is it for dot product. We multiply corresponding coefficient. 2 times 3, 6, minus 3 times plus lambda minus 3 lambda, 5 times minus 2 minus 10, and this product, and this is equal to 0. 6 minus 10 is minus 4, so we have minus 3 lambda minus 4 equals 0. So minus 3 lambda equals 4. By the time 4 crosses to the right, dividing both sides by minus 3 yields lambda equal to minus 4 all over 3. So the value of lambda for which these two vectors are orthogonal is minus 4 all over 3. If A is equal to 2i plus 3k, B equal to 4i minus 6k, and C is equal to 20i minus 6k, right? Find the scalars lambda and beta if C is the resultant of lambda A and beta B. Now, the question says that vector C is the resultant of lambda A and beta B. What is lambda A and what is beta B? That's the next question. This is vector A already, A equal to 2i plus 3k. So lambda A is the product of lambda and vector A. That means we are going to multiply everything here by lambda. And that will give us 2 lambda I plus 3 lambda k. So this is lambda A. Beta B is multiply vector B by beta. So that will be 4 beta I minus 6 beta k. The resultant of lambda A and beta B is C. What does that mean? It means that C is equal to lambda A plus beta B. And so vector C is what? 20i minus 6k. So 20i minus 6k is equal to what's lambda A? This 2 lambda I plus 3 lambda k plus what's beta B? That's 4 beta I minus 6 beta k. 20i minus 6k. I have two terms in I here. So I can say this is 2 lambda plus 4 beta I. This is 3 lambda k minus 6 beta k. So I can say plus 3 lambda minus 6 beta k. I will now compare coefficients. Okay. The coefficient of I here is equal to the sum of the coefficient of I at the right hand side. So 20, which is the coefficient of I, is equal to 2 lambda plus 4 beta. And if I reduce this, dividing both sides by 2, we have 10 is equal to lambda plus 2 beta. Let's call this equation 1. The coefficient of k here is minus 6. And here it is 3 lambda minus 6 beta. So compare, it is minus 6 equal to 3 lambda minus 6 beta. So if we divide both sides by 3, we'll be having, this will be minus 2 equal to lambda. This is 1. If we divide by 3, divide this one by 3, we have minus 2 beta. Equation 2. We can easily eliminate lambda from the equation by subtracting any of the equation from the other. So if we say equation 2 minus 1, for example, we're having minus 2 minus 10 equal to lambda minus lambda, lambda minus lambda, minus 2 beta, minus 2 beta. Minus 2 minus 10 is minus 12. Lambda minus lambda is 0. Minus 2 beta is minus 4 beta. Minus cancel minus 4 here 1, 4 here is 3. So beta is equal to what? 3. What is lambda? Let's plug in 3 for beta in any of the equation to determine lambda. So into equation 2, for example, in place of beta here, we're going to write 3. So minus 2 is equal to lambda minus 2 times 3, right? We have minus 2 equal to lambda minus 6. So minus 2 plus 6 is equal to lambda. And what does this mean? Minus 2 plus 6 is 4. So lambda is equal to 4. The question says that we should find the scalars lambda and beta. We just got lambda equal to 4, beta equal to 3. So which of these options is correct? Lambda is 4, beta is 3. Lambda comes before beta by the question. Find the scalars lambda and beta. So this should be the correct option. Alright, so lambda is 4 and beta is 3. Option C. Here we are to find the equation of the line joining the point, this point, to the intersection of the lines 3x plus y equal to 7 and 4x plus 2y equal to 10. Okay. This point is to the intersection of these two lines. So what we have to do first of all is to determine the point of intersection of these two lines. That is the point where these two lines meet. Alright. And to do that, we'll solve the simultaneous equation. 3x plus y equal to 7. I can actually reduce this equation into this by dividing both sides by 2 because 2 is common. So I have 2x plus y equal to 5. Okay, let me call this my equation 1. Let me call this equation 2. So I can easily eliminate y. Okay, let me solve by elimination. I can easily eliminate y by saying equation 1 minus equation 2 or equation 2 minus equation 1, because if I say y minus y is going to be 0. So subtracting equation 2 from 1, we'll be having 3x minus 2x plus y minus y equal to 7 minus 5. 3x minus 2x is x, right? Y minus y is 0. 7 minus 5 is 2. So x is equal to 2. What is y when x is equal to 2? It's just to substitute 2 for x into any of the equations, 1 or 2, to get y. So if I plug in 2 for x in equation 2, it will be 2 times 2 plus y equal to 5. Right? 2 times 2 is 4. So 4 crosses and we have y equal to 1. So x is equal to 2, y is equal to 1. So the point of intersection of the two lines, alright, is this 2, 1. So we have to find the equation of the line that joins this point and this point. So this point is 1, 2. So we have 1, 2. Then we have a straight line like this. For example, this is x1, y1. And here we have x2, y2. Here we have a variable point. Let's say s, y. The equation of the straight line would be this: y minus y1 all over x minus x1 is equal to y2 minus y all over x2 minus x. This is the equation we're going to make use of. Now, what is y1? This is x1, y1, x2, y2. So we have y minus y1 is 1, sorry, is 2, x minus x1 is 1, y2 is 1 minus y, x2 is 2 minus x. Okay, so let's cross multiply. Y minus 2 times 2 minus x is equal to this times this, x minus 1 times 1 minus y. Okay, so we have y times 2 is 2y, y times minus x is minus xy, minus 2 times 2 is minus 4, minus 2 times minus x is plus 2x. X times 1 is x times minus y is minus xy, minus 1 times 1 is minus 1, minus 1 times minus y is plus y. Minus xy will cancel minus xy, right? Okay, so we are having 2y. If this y cross, it turns to minus y. So 2y minus y is y. We have 2x, okay, and plus x at the right hand side. So if the s cross, it turns to minus x. So 2x minus x is plus x. We have minus 4, right, minus 1. If the minus 1 cross, it turns to plus 1. So it will now be minus 4 plus 1, which is minus 3, equal to 0. So if you write it in the form that says y equal to mx plus c, which is the gradient intercept form, y will be equal to minus x plus 3. So this is it. Whichever one you choose is correct. Find the angle between the two vectors a equal to I plus j plus k and b equal to minus I plus 2j plus 3k. To determine the angle between two vectors, we make use of the formula that says the dot product of a and b is equal to the modulus of a times the modulus of b times cos theta. So this is the angle between the two vectors, theta. Now, what is a dot b? What is the modulus of a and what is the modulus of b? So let us determine a dot b. A dot b, which is the dot or the scalar product of the two vectors, is this. We multiply corresponding coefficient. The coefficient of I here is 1 and here is minus 1. 1 times minus 1 is minus 1. The coefficient of j here is 1 and of j here is 2. 1 times 2 is 2. Of k here is 1, of k here is 3. 1 times 3 is 3. 2 plus 3 is 5. 5 minus 1 is 4. So the dot product of a and b is equal to 4. Now, what is the modulus of a? It is the square root of the coefficient of I here is 1, so 1 squared, plus of j here is still 1, 1 squared, of k there is 1, 1 squared. So that one is actually 1 plus 1 plus 1, that's 3. Root 3 is the modulus of A. What is the modulus of B? In similar fashion, minus 1, which is the coefficient of I here, square it. 2 squared, right, plus 3 squared. 1 plus 4 plus 9. 1 plus 4 plus 9. 9 plus 1 is 10. 10 plus 4 is 14. So this is the square root of 14. And that is the modulus of the vector B. So we can now determine theta. A dot B, okay, is 4, right? So 4 is equal to modulus of A. What is it? Root 3. Modulus of B, root 14. Cos theta. Okay, we have 4 equal to root 3 times root 14. That is the square root of 3 times 4 is 12. Take away 1. 3 times 1 is 3 plus that one is 4. So we have root 42 cos theta. So if you divide both sides by root 42, 4 all over root 42 is equal to what? Cos theta. And so, okay, 4 over root 42 is equal to what? Cos theta. So that theta will be the cosine inverse of 4 all over root 42. And this is equal to 51.887. So if I approximate this to the nearest whole number, like the question approximated, so this is approximately 52 degrees. So the angle between the two vectors is 52 degrees. Look at it. 8 is up to 5. So we'll take it as 1. Add to this one here becomes 2. That's how we got 52. And every other number here becomes 0. Alright, so the answer is 52 degrees. Find the equation of a straight line through the point, this point, parallel to this line, 3x minus 4y plus 7 equal to 0. Okay. Now, for two lines that are parallel, their gradients are equal. The principle is that if two lines are parallel, then they have equal gradient. So the gradient of this line is equal to the gradient of the line that passes through this point. Okay. So what is the gradient of this line? We can write this equation in the gradient intercept form. That is y equal to mx plus c, where m is the gradient. So let us make y the subject of the formula here. 3x minus 4y plus 7 equal to 0. From here we have minus 4y is equal to 7 will cross and turn to minus 7. 3x will cross and turn to minus 3x. So we have minus 3x minus 7, right? Okay, minus is common to all of them. Minus 4y minus 3x minus 7. This means that we can divide all through by minus to obtain 4y equal to 3x plus 7. So dividing both sides by 4, y is equal to 3x over 4 plus 7 all over 4. So this is the equation of this line in the gradient intercept form. If we compare this and this, y is y, c is 7 over 4, m is 3 over 4, right? M is the gradient. So the gradient of this particular line is 3 over 4. M equal to 3 all over 4. So based on the principle of parallelism of two lines, their gradients are the same. So let us determine the equation of the line that passes through this point. This is one point. We can determine the equation using the gradient and 1 point form of the equation of a straight line. Gradient and 1 point form. This is gradient intercept form. Gradient and 1 point form says y minus y1 equal to m, which is the gradient, into x minus x1. All right, so m for this line is 3/4. Since the two lines are parallel, it is also 3/4 for this line. That's the point. Okay, x1 is -2, y1 is 3. So the equation is this: y minus y1, which is 3, okay, m is 3/4. 3/4 into x minus x1, which is -2. Said x1 is -2, y1 is 3. So x minus -2. So y minus 3 is equal to 3/4 all into x plus 2. So if I cross multiply, we'll be having 4 times everything here. That's 4y minus 12 equal to 3 times x, 3x. 3 times 2, 6. So 4y is equal to 3x plus 6 plus 12, right? If we collect like terms, 4y is equal to 3x plus 18. So we can choose to leave it this way, or if we divide both sides by 4, we are having y equal to 3/4 of x, okay, then plus 18/4. 18/4 is 2 here is 9. 2 here is 2, so 9/2 plus 9/2 plus 9/2. They are the same. Find the value of alpha squared plus beta squared if alpha plus beta equal to 2 and the distance between the points this and this is 3 units. Okay, the question says that the distance between these 2 points, 1 comma alpha and beta comma 1, is 3 units. So let us determine the distance between these 2 points first of all. Using the distance formula, distance between 2 points is the square root of x2 minus x1 squared, right, plus y2 minus y1 all squared. So the distance between the 2 points is 3 units. So 3 is equal to the square root. What's x2? This is x1, y1, x2, y2. So x2 minus x1, beta minus 1, beta minus 1 all squared, plus y2 minus y1, 1 minus alpha all squared. If we take the square of both sides so as to eliminate this square root, we'll be having 3 squared, which is 9, alright, is equal to beta minus 1 all squared plus 1 minus alpha all squared. The square root has been eliminated by the square. So I'm working with this now. So 9 is equal to, now let's expand beta minus 1 all squared. That will be beta squared. Okay, beta squared, then 2 times beta times minus 1. That's minus 2 beta. Then minus 1 all squared is plus 1. In the same vein, we expand 1 minus alpha squared. That will be 1 squared is 1. 2 times 1 times minus alpha, minus 2 alpha. Minus alpha all squared is plus alpha squared. So the question is asking for the value of alpha squared plus beta squared, right? So I can see alpha squared plus beta squared. Let's make alpha squared plus beta squared the subject of the formula. 1 plus 1 is 2, right? 2. So 9 minus 2, that's 7, equal to alpha squared plus beta squared. Then we're having minus 2 beta minus 2 alpha. Minus 2 beta minus 2 alpha. But the question gave us the value of alpha plus beta, and that's 2. It says alpha plus beta equal to 2. So see something. This is 7 equal to alpha squared plus beta squared. Minus 2 is common to both of these terms. So if I bring minus 2 out, I'll be left with beta plus alpha, which is the same thing as saying alpha plus what? Beta. And alpha plus beta by the question is what? 2. Therefore, this equation is now equal to 7 equal to alpha squared plus beta squared minus 2 times 2. Alright, so we have alpha squared plus beta squared minus 4. So we are working with this now, this and this. If 4 cross to the other side, it becomes 11. So 7 plus 4 is equal to alpha squared plus beta squared, and that's 11. So 11, which is 7 plus 4, is alpha squared plus beta squared. So option D is the correct option. Find the angle between the lines 3y minus 4x equal to 2 and 7y equal to x plus 1. Okay, we have to find the angle between these two lines. Given two lines, alright, two lines with gradient m1 and m2, we can determine the angle between these two lines. So the angle, which is theta, we have tan theta equal to m1 minus m2, right, divided by 1 plus m1 m2. m1 is the gradient of the first line, m2 is the gradient of the second line. So theta is the angle between the two lines. Now, what is the gradient of this line and what is the gradient of this line? All right, we are taking the gradient of this first line as m1 and the gradient of this second one as what? m2. So the question is, what is the gradient of each of these lines? Let's see it. Now, for the line that says 3y minus 4x equal to 2, we can write each of these two lines in the gradient intercept form of the equation of a straight line, which is y equal to mx plus c, gradient intercept form. So to do that, we are going to make y the subject of the formula. So 3y is equal to 2 plus 4x, all right? If we divide both sides by 3, y is equal to 2 over 3 plus 4x all over 3, all right? It's the same thing as saying y equal to 4x over 3 plus 2 all over 3. So comparing these two equations, you can see that m is equal to 4 over 3, right? And the y-intercept is 2 over 3. So m1 is 4 over 3. This is m1. What is m2? The equation of the line is 7y equal to what? X plus 1. So let's make y the subject of the formula. Let's write it in the same gradient intercept form. Alright, so y is simply equal to x all over 7, dividing both sides by 7, plus 1 all over 7. So the coefficient of x here, which is 1 over 7, is the gradient of this line. So m2 from here, m2 is 1 all over 7. Look at it, the coefficient of x here, 1 all over 7. That's m2. Applying the formula, tan theta is equal to m1. What is m1? 4 over 3 minus m2, which is what? 1 over 7. 1 all over 7 divided by 1 plus 4 over 3 times what? 1 all over 7. So we have this. Okay, let me simplify this in a very easy way. The LCM is 21. Alright, so I can say 7 times 4, 28. Okay, 3 times 1 is 3. It's the same thing. 21 divided by 3 is 7. 7 times 4, 28. 21 divided by 7 is 3. 3 times 1 is 3. All divided by 4 times 1 is 4. Okay. 3 times 7 is 21. So that one is actually 1 plus 4 over 21. 21 times 1 is 21 plus 4 all over 21. So 28 minus 3 is 25. So we have 25 over 21 divided by 21 plus 4 is still 25. 25 all over 21. Wow. Divide the two of them are the same. So the answer is going to be 1. This divided by this is 1. So tan theta is equal to 1. That means that theta is the tangent inverse of 1. If we take the tan inverse of both sides to get theta. And the tan inverse of 1 is 45. So we have 45 degrees as the angle between the two lines. And that option is option D, 45 degrees. If the midpoint of the line MN is this, and the point M has this coordinate, find the coordinate of the point N. Alright. The midpoint of the line MN is 2, 3. Okay. So actually the line MN has its endpoint at M and N. Alright. It's like a line segment M and N. So M has the coordinates minus 2, 1. Minus 2, 1. The center point, which is the midpoint, has this coordinate 2, 3. 2, 3. Now, what is the coordinate of this N? Let's call it X, Y. So we have to look for the coordinate of point N. So we just said let it be X, Y. The formula for midpoints of a line segment, alright, is this. The midpoint is x1 plus x2 all over 2, y1 plus y2 all over 2. So the midpoint has been given. It is this. So I'll write 2, 3 is equal to, what is x1, what is x2, what is y1, and what is y2? Point M is minus 2, 1. Point N is x, y. So we can choose any one to be x1, y1, and the other one x2, y2. Let's choose this as the first point, having the coordinates x1, y1. And this should be x2, y2. You get it? Minus 2 is x1, 1 is y1. X is x2, y is y2. So fixing those values into this equation, we have x1 is minus 2 plus x2 is x. So we have minus 2 plus x all over 2, what's y1? 1, what's y2? Y. 1 plus y all over 2. So this is an equation. Let's determine the value of x and y. Corresponding points are equal. 2 here is equal to this first point here. That's 2 is equal to minus 2 plus x over 2. 3 is equal to this value of y here, the point y here. 1 plus y all over 2. So we have that 2 is equal to minus 2 plus x all over 2. So if we cross multiply, we have 4 equal to minus 2 plus x. Making x the subject of the formula, if we take this one to the other side, it becomes 6. So 6 is equal to x. X is 6. What is y? In the same way, 3 is equal to 1 plus y over 2. 1 plus y all over 2. So if you cross multiply, 2 times 3 is 6. Alright, equal to what? 1 plus y. So if 1 cross returns to minus, we have 6 minus 1, which is 5, equal to y. So x equal to 6 and y equal to 5. So therefore, n has the coordinate 6, 5, because s comes before y. So s, y is equal to this. This is the coordinate of the point n. And we can see that in option D, right?